Welcome back. I'm the backend developer. Today we're talking about adaptive API rate limiting for microservices, how to stay scalable, reliable, and secure as traffic and risk change in real time. Static rate limits are simple, a fixed number of requests per time window. But in microservices, they often fail because traffic is bursty, dependencies degrade, and one size never fits every tenant, endpoint, or moment. Adaptive rate limiting changes the limit based on signals, service health, latency, error rates, queue depth, or per customer behavior. The goal is to shed load gracefully and protect critical paths without blanket throttling. Core building blocks stay consistent. Identify the caller, choose a scope like per API key or per route, keep counters in a shared store, decide what to do on exceed, reject, delay, or degrade, and always emit metrics for tuning. Under the hood, you'll typically see token bucket and leaky bucket for smoothing bursts, fixed and sliding windows for simplicity, and concurrency limits when the real constraint is in-flight work, especially under high latency. In distributed microservices, enforcement matters. You can rate limit at the edge gateway, inside each service, or both. For consistency, use a centralized store like Redis or a coordinated approach via service mesh filters, then keep fallbacks for partial outages. Rate limiting is also security. Use it to slow credential stuffing, scraping, and abusive automation. Add smarter rules. Per IP plus per user, dynamic penalties after repeated failures, and separate limits for expensive endpoints. A practical Python-style flow looks like this. Extract a key, fetch a bucket from Redis, refill based on time, consume a token, and if it's empty, return a 429 with a retry after hint. Keep everything observable, counts, drops, and latency impact. For implementation, start with what you already run. API gateways like NGIN, X, or Kong, cloud front doors, Redis-based limiters, and service mesh options like Envoy filters. Choose based on where you need consistency, latency, and operational control. That's adaptive rate limiting. Protect reliability, keep scaling smooth, and raise the cost of abuse without blocking good users.